We're now at week 5, our final week of the course, and I want to go over some of your assignments for this week. So let's take a look at Module 5. Your learning materials for this week, you're going to be looking at 2 sections in the Blue book, the particular challenge section and then the genetics of introduction section. You're going to be looking at part of chapter 19 and 20 in the Frankham book on captive management of groups. There's an article on some of the issues that you face with the public when you try to do a reintroduction. So if part of your strategy for your species is reintroduction, then you need to think about what some of those complications might be as we try to reintroduce species back into wild habitats. Here you have these genetic tables. Now remember, you're doing your course project, and these genetic tables will allow you to find some of the information on your animal. You're going to need data from these tables in your project. So those are your learning materials for the week. In your first discussion, you're going to think about that issue that we have with the timber rattlesnake and the public's reticence to accept being reintroduced into the area. You're going to write a post about the importance of reintroduction, and you want to do it with your species. So you're not doing it on the rattlesnake, you're doing it for your species. And they talk about writing an op-ed piece. So this is looking at a very specific type of article you might write for a local newspaper. Here, if you click on this op-ed project, it'll talk a little bit about how to write a good op-ed piece. So you want to take a look at that. And then, of course, you're also going to reply to 2 fellow students thinking about some of those guidelines in this op-ed project, what improvements could be made for their case. Could their case be strengthened by adding certain concepts or changing some of the terminology? Your next assignment, you'll be using the same simulator that we used a few weeks ago. Before, you looked at population size differences. So you had created 2 different populations, a large and a small population. And then you also ran simulations where you had 1 population versus 5 populations. And remember, in that, what you were doing is looking for fixation of alleles and how long did it take for alleles to become fixed in those different situations. What is the effect of population size on fixation of alleles? Because remember, fixation of alleles means we've lost genetic diversity, and that's what we're after. So does population size affect loss of genetic diversity, and does having more than 1 population affect loss of genetic diversity? So we looked at that a few weeks ago. What they're going to do now is to essentially look at the same situation, but we're going to introduce migration. But what would happen if we had these populations, but we had individuals coming into the population from other areas, and of course bringing their alleles with them? So if you had fixation in 1 population, but then you had migrants coming in, bringing in the allele that had been lost, now you've reintroduced genetic variation into that population. So we want to kind of understand, how does migration influence that? That obviously can influence our decisions on how we create and manage populations. You're going to be doing basically 8 different simulations. As it says here, you're going to start with a small population, and you're going to run that population, including migration. So what I would do is go back to what you did a few weeks ago, select the same population sizes, but now we're going to have migration. Before, you didn't have migration in there. You ran this with small and large populations, 1 versus 5 subpopulations. Now we're going to introduce migration. So again, if you can reduce the number of variables that you put in these, you can draw better conclusions and you can compare better. My advice would be to use the same populations you used a few weeks ago for your small and large sizes. Now all you're changing is the migration and then the migration rate. So we're going to look at 2 different migration rates. On the simulation, we're going to set this to whatever we did a few weeks ago. I'm going to just pick 25 here. We're at first going to set this to 1 population. And we're not going to change anything else here. It's the same as it was a few weeks ago. All we're going to do here is put in island migration. And the first thing it wants us to do is to put in 0.10. We have 10% of the population coming in. So if we have 100 individuals, 10 new individuals are going to join this population. And then we're going to hit go. And we're going to look to see what that does. And then we're going to come up here and we're going to change it to 0.5 because it wants now 50% migration. And we're going to see what that does. And then we're going to also change the number of populations here. here. So we're going to run the same thing we just did, but now this is 5. So we're going to get 2 more runs here. All right, so we now have 4 runs at the small population size. We have a run where there was 1 population and 0.10 here, 5 populations and 0.10 here, and then 1 population where this is 0.50 and 5 populations where it's 0.50. So for your small population size, you now have 4 runs. Then you're going to change it to a higher population size. Again, go back and see what you did a few weeks ago. I'm just going to throw 75 in there, and we're going to do exactly the same thing. What I would recommend you doing is using the snipping tool, because it tells you in the instructions that it wants you to show the graph. So with the snipping tool, you can go into your start menu and look for the snipping tool. Just start typing in snip and it should come up. With the snipping tool, you're just going to say new, and then you can highlight all of this and then put that into your Word document. So once I have it in here, I can right click, I can copy, I can go over to Word, and I can paste it in. You're going to have 8 of those graphs. What you want to do is to compare what's going on in these 8 different scenarios. Now think about what you're changing. You're changing population size, so you have a small and a large population. For each of those, you're also creating either only a single population, or you might have 5 subpopulations. So how many populations of those do you have? Are they split up or not? And then you're also changing migration. When you go to make your conclusions based on your data, you want to compare those things. What happens with large versus small? What happens with few versus many populations? What happens with low versus high migration? How does that influence the allele frequency? And we're really looking at how does that influence genetic diversity? Do populations reach fixation faster or slower? When we have 5, do they all reach fixation for the same allele? Or do some populations have A1 fixed and other populations have A2 fixed? If that's the case, then having more populations helps you maintain genetic diversity because you didn't lose the same allele in all of your 5 populations. The second major thing I want to remind you to do when you're discussing it, please refer to the data. Look at the data and say, in this one, we reach fixation after 20 years. Over here, we reach fixation after 50 years. Bring the data into it. As scientists, we want to start incorporating data into our language and into our evidence, not just general statements. And you're going to definitely want to do that for your project. So you're going to then compare these, and then as you're comparing them, also at the end, think about how that might impact your decisions on how you're going to manage your captive population. And of course, you have your grading rubric down here. So you want to illustrate that you understand what you're seeing in those graphs. That's what the first one is asking you to do. And you're also analyzing what the implications of those data are for your population. Your next assignment this week is on the course project, your species survival plan for your species. And I'm going to create a separate video for that because I want to really make sure that we go over that in detail, and I don't want this one to get too long. Look for another video this week that specifically talks about the course project. If you have any questions throughout the week on any of your assignments, please let me know. Please also remember this is the last week of the course, so late assignments cannot really be dealt with because we have to get grades in. So you want to make sure that you get this week's assignments in on time.